वेलकम फ्रेंड्स, वेलकम बैक टू माय चैनल। वेलकम टू डीजे डिकोड्स, आपका ट्यूशन वाला भैया। हेलो एवरीवन, टुडेस टॉपिक इज हाइपोथेसिस टेस्टिंग एंड hypothesis testing is a very vital topic when it comes to statistics. Today in this video we'll discuss about what actually hypothesis is, what is null hypothesis and what is alternative hypothesis, what are the steps involved during hypothesis testing. We'll study in details about each of the steps. We'll discuss about one tail test and two tail test. We'll make sure that your basic concepts gets cleared in this video. We'll discuss about the importance of level of significance in hypothesis testing. We'll discuss about two popular methods of hypothesis testing, that is ZTest and TTest. We are going to explain in details what are the conditions that needs to be looked, which will ultimately help us to decide whether we should go for Z-test or T-test. And we will discuss about the importance of hypothesis testing in statistics. And in the next video, we will discuss about F-test, chi-square test, ANOVA test and Fisher's T-test. So friends, before getting into the topic of hypothesis, it's very important for us to understand what actually hypothesis is. Why do we do hypothesis and what are the conditions that we should keep in mind before doing the hypothesis testing. We should be sure about the claim. We should be aware of the methods that we should select for doing the particular hypothesis testing. Hypothesis testing is about drawing a conclusion to support a particular claim based on some evidences by studying the characteristics of a sample population. You do not do hypothesis testing on the entire population. You take out a sample, you study that sample and you do the hypothesis testing and come to a conclusion based on the sample data. So now let us go straight into the chapter and discuss about hypothesis. So friends, let us discuss about what is hypothesis. A hypothesis is basically a statistical approach of testing a claim. Okay, and null hypothesis and alternative hypothesis are the basic components that you need to formulate before performing the hypothesis testing. So let us discuss about null hypothesis. What is null hypothesis? It is basically the currently accepted value denoted by H0 or H of 0. And what is alternative hypothesis? It is the claim that is to be tested, which is denoted by HA or H1. So the main objective of hypothesis testing is to check if we have enough evidence to support our claim. That means to support our alternative hypothesis. And based on the testing, we either reject the null hypothesis or we fail to reject the null hypothesis. So now we'll discuss about the steps of hypothesis testing. So I believe that you have got a basic idea of what actually hypothesis is. Suppose there is a currently accepted value, say for example the IQ of class 5 students. Okay, it has been accepted that the IQ of class 5 students is say 80. Now a researcher or an analyst comes up and says that I am challenging the currently accepted value. I am claiming that the IQ of class 5 students is not 80. It is either less than 80 or more than 80, or it can be said it is not equal to 80. Then what he is doing? He is proposing an alternative hypothesis that is opposite to the null hypothesis, mean it is opposite to the currently accepted value. Now based on the testing, he will be able to come to a conclusion. He will check whether he has got enough evidence to support his claim, and based on that he will be able to reject the null hypothesis or he will be able to reject the alternative hypothesis. This is what is hypothesis testing. So friends, let us have a look on the steps that are involved in hypothesis testing. So there are 5 steps. Let us go through the steps and we'll discuss in details about each of the steps. So let us first go through the 5 steps. The first step is state the null and alternative hypothesis. The second step is choose the level of significance. The third step is find the critical values. The fourth step is find the test statistics. So you need to know what is the test that you are going to perform, whether you are going to perform a Z-test or a T-test or some other test. Okay, and the fifth step is draw your conclusion. Either you will reject the null hypothesis against the alternative hypothesis that you are claiming, or you fail to reject the null hypothesis. Okay, so rejecting the null hypothesis does not mean that the null hypothesis is false. It means that there is not enough evidence to support that claim. Let us go into each of the steps and understand in details. So we have discussed about the null and alternative hypothesis. So now let us discuss about the level of significance and how is it important in hypothesis testing. Now friends, let us discuss about the level of significance. Before discussing and going into the level of significance, let us discuss about the types of error in hypothesis testing. If you consider this box, you will find that when the null hypothesis means H0 is true and still we are rejecting the null hypothesis, it would be denoting type 1 error. Okay. Now if the null hypothesis is false but still we are accepting the null hypothesis, this will be signifying the type 2 error. Okay, and if you see the other two decisions, the null hypothesis is false and we are rejecting the null hypothesis, that means it is a correct decision. And the null hypothesis is true and we are accepting the null hypothesis, so it is also a correct decision. Now let us come to level of significance. So what is the level of significance? The maximum probability of type 1 error is called the level of significance. Got it? So the level of significance is denoted by alpha. Now if you consider the normally distributed graphs, you will find that these regions are marked in red and the remaining regions are marked in white. So what does the red region denotes? The red region denotes the rejection region and the remaining area denotes the acceptance region. Now how do we relate the level of significance with the acceptance or the rejection region? The area under the curve means the area under the rejection region, that is marked in red, is basically the level of significance. Got my point? If the level of significance is 0.05, means the area under the curve, the area of the red region is 0.05 for a one-tailed test, and for a two-tailed test it is 0.025 on both sides. It is symmetrically distributed. Now before going into one-tailed and two-tailed test, let us clearly understand what is the level of significance. For making you understand the level of significance, just take a small example. Just take an easy example. The IQ of class 10 students is 100. This is a accepted value, means this is the null hypothesis. We are considering the IQ of class 10 students is 100. Okay, so this is the null hypothesis. This is the currently accepted value. But a researcher comes up. He says that this is not correct. He can propose that the IQ of class 10 students is more than 100 or it can be less than 100, or you can say it is not equal to 100. It can be more than 100 or it can be less than 100, but it is not equal to 100. So these can form the alternative hypothesis for the researcher. Now if we consider the first part, if we consider the first alternative hypothesis stating that the IQ of the class 10 students is more than 100, the currently accepted value is 100, but the researcher is claiming that it is more than 100, then how will we represent the same in the normal distribution curve? So when this is more than 100, it means this is the mean value. Okay, see, the middlemost value represents the mean value. So if it is more than 100, it will be on the positive side, it will be on the right side. So this alternative value is lying somewhere right of this mean value. If it is less than 100, it means it lies on the left of the mean value. Okay, and if it is not equals to 100, means it lies somewhere around here. It can be 80, it can be 90, it can be 101 also, but not 100. So this denotes the two-tailed test, where the researcher is claiming that the IQ of class 10 students is not equal to 100. It can be more than 100 or it can be less than 100, but it cannot be equal to 100. So in such situations, it is represented by two-tailed test, means the rejection region will be on the extreme two tails of the normally distributed curve. Now say we are considering this one as the alternative hypothesis and this is the null hypothesis. So we are looking at this particular diagram. The level of significance is 0.05, means the level of confidence is 95%, means we are 95% sure of what we are claiming, right? If the confidence level is 95%, means it is 0.95, and level of significance would be 1 minus 0.95, that is 0.05. Okay, it can be, the level of confidence can be 99% also, 90% also. Okay, so this is the most commonly used level of significance. So now where does this alpha 0.05 lies on this particular curve? So this is the rejection region marked in red. The area under this rejection region is 0.05. Considering this, we have to use the Z-test or the T-test depending upon the population standard deviation and the sample size. Depending upon the population standard deviation and the sample size, we have to decide whether we should use Z-test or T-test. So if we are using a Z-test, we have to find the critical value that is corresponding to the area under the curve as 0.05. And what does the critical value signifies? The critical value will separate the rejection region from the acceptance region. So this is basically the critical value which is separating the rejection region from the acceptance region. This is the critical value. These are the critical values that is separating the rejection region from the acceptance region. We find this from the Z table or T table. So the level of significance is basically the area under the rejection region. Okay, now according to the test statistics, whether we are doing Z or T test, so we need to find the test statistics value by using formulas which we will discuss in the later parts of this video. So the test statistics value has to be found out using those formula. Okay, after finding the test statistics value, we need to put that value and check where is it lying on the normal distribution curve. If it is lying on the red region or the rejection region, so we need to reject the null hypothesis, and if it is lying on the acceptance region, it should be accepted. So I believe that you are clear with the one-tailed test and two-tailed test, how it can be represented in the normal curve, what is the importance of level of significance, the level of confidence, the errors in hypothesis testing. You are now well accustomed with these things. Now let us see, when do we use Z-test, when do you use T-test, how to find the critical values, how to compare the test statistics values with the critical values, and then come to a conclusion. So you have to keep in mind that the test statistics value, be it a Z value or T value, the test statistics value has to lie in the acceptance region in order to accept the null hypothesis, and if it is lying in the rejection or the red region, then you have to reject the null hypothesis. This is the basic funda of hypothesis testing. Now let us discuss with some examples. Now friends, let us discuss about Z-test and T-test. When to do Z-test or when to do T-test. What are the conditions that needs to be fulfilled for doing T-test or Z-test? So let us have a look on the board. See, for T-test, these two conditions needs to be fulfilled. Number one, the standard deviation of the population is unknown, and number two, the sample size should be less than 30. It clearly shows that for T-test, the sample size should be small. If both the conditions are satisfied, then we can go for T-test. If any of the conditions are not satisfied, then we should go for Z-test or Z-test. Now let me show you a question and let us understand whether we should go for Z-test or T-test for that particular question. Let us understand the conditions. What is the standard deviation of population? What does the population means? And what is the sample size and what does it mean? Now friends, let us have a look on the particular question and let us find out whether we should go for Z-test or whether we should go for T-test. Let us go through the question first. The average test score for an entire school is 75 marks with standard deviation of 10. What is the probability that a random sample of 5 students scored above 80? We have got the sample mean. Okay, the sample mean is 80. The sample is of 5 students. This is the sample. So the sample is of 5 students and the sample mean is 80 marks. Now the population standard deviation is given and the average marks of the entire population is also given. So this is the population mean, which is 75, and the standard deviation of the population is 10. These are the parameters that are present in our problem. Now we have to decide whether we should go for Z-test or T-test. So as we discussed, the two conditions that needs to be fulfilled for T-test are: number one, the population standard deviation should be unknown, okay, and number two, the sample mean should be small, less than 30. These are the two conditions that needs to be fulfilled so that we can do T-test. So let us check. Now in this problem, the population standard deviation is known. It is given 10. Okay. So this condition is not satisfied, but the sample size is 5, which is less than 30. This one is satisfying. But since both the conditions are not being satisfied here, we cannot go for T-test. In this case, we go for Z-test. Okay. Now, if we change the question a bit, suppose this standard deviation of the population mean is not present in the question. So I am erasing this. Now this one is not given. Now let us have a look on the two conditions for T-test. The standard deviation of the population is unknown. Yes, it is unknown. So this one is being satisfied. and the sample size is 5, which is less than 30. So both the conditions are getting satisfied. Then in such case we go for t-test. Okay. Now instead of the question that was given, suppose the standard deviation of the sample population is given. Okay. See, suppose the standard deviation of the sample population means this sample population is given as 10. So in that case also we can go for t-test, because the standard deviation of the population is not given, but the standard deviation of the sample population is given. So if the sample population standard deviation is given, that does not have any impact on the t-test criteria. So in that case also we can go for t-test. So it is very evident that when should we go for t-test and when should we go for z-test. Now friends, let us take an example. Let us take a problem and solve it using z-test or t-test. How do we form the null hypothesis and alternative hypothesis? How do we find the critical region? How do we find the test statistics? And how do we draw our conclusion and establish our claim? So let us take a problem and try to solve using Z or t-test. So before solving a problem, let us understand what is test statistics. So if you can see on the board, there are two formulas. The first formula is x bar minus mu divided by standard deviation of the population divided by root n. If you are going for z-test, this would be the formula, and if you are going for t-test also, this would be the formula. The standard deviation here would be representing standard deviation of sample mean, okay, and for z-test it will be standard deviation of the population. This is the basic difference. X bar is the sample mean, mu is the population mean, and n is the sample size, okay. And if you are dealing with proportions, then the formula would be the bottom one, p bar minus p divided by root over p into 1 minus p divided by n, where p bar is the proportion of sample and p is the proportion of population. The objective of test statistics is to find the z value or the t value and plot that value on the normal distribution curve, and we have to check whether that z value or t value or the test statistics value is lying on the rejection region or the acceptance region. Okay, if the value is lying on the rejection region, that means the null hypothesis has to be rejected, and if it is lying in the acceptance region, that means the null hypothesis has to be accepted. This is the basic funda of test statistics. So now let us have a look at a problem. Now friends, let us go through the question that is shown on the board. The average price of products in a store is 100 rupees. A researcher believes that the average price of the products are lower than 100. A random sample of 5 products were tested. The price of those 5 products were found out to be 69, 79, 89, 99 and 109 with standard deviation of 15.81. Now, is there enough evidence to suggest that the average price of the products is lower than 100? Now, in the question it is been given that the average price of all the products in a store is 100 rupees. Okay. Now the researcher believes that the average price of the products in the store is lesser than 100. It can be 90, it can be 99, it can be 98, it can be 80 also, but lesser than 100. Now in order to prove his claim, a random sample of 5 products were tested and the average price of those 5 products were found out to be 69, 79, 89, 99 and 109. This means this is the sample and the average price of these 5 sample products were noted, and the standard deviation of this sample was 15.81. Now we need to test the hypothesis and check whether there is enough evidence to support the claim of the researcher. Let us first begin. Our first step, as we had discussed, the first step of hypothesis was to state the null and alternative hypothesis. Okay, so first we will state null and alternative hypothesis. Okay, so basically we will have to state H0 and HA. Okay, now in the question, if you go through the question, you will find that the currently accepted value means the average price of products is assumed to be 100. It is given in the question. So this is 100, but the researcher believes that the average price of the products is less than 100. So we are done with the first step. Okay, in the next step we have to choose the level of significance. Now my friend, if the level of significance is not provided in the question, we go with the most commonly used level of significance, that is 0.05, means it is having a confidence level of 95%. So number 2, we select level of significance, that is alpha. So alpha we have selected 0.05. Okay, so we are done with the first two steps. The third step is to find the critical values, means the critical value separates the rejection region from the acceptance region. So let us first draw a normal curve to make you understand about the problem, and then we will find the critical values. So let us draw the normal curve. So friend, this is the normal curve. The level of significance is 0.05 and the alternative hypothesis is stating that the average price is less than 100. This is what the researcher is claiming. So less than means the alpha 0.05 value will lie on the left side of the tail. Now we mark the rejection region. It would be lying on the left side of the tail. Alpha value 0.05 means the area under this red zone is 0.05. We have to find the corresponding critical value from the Z table or the T table, depending upon what test are we doing. So before finding the critical value, let us first understand the alpha value. So this is what the alpha value is stating. The area under this red region is 0.05. Okay, now this is the average price, which is 100. So the corresponding value would be 0. If we are doing a Z test or a T test, this value will corresponding to 0. This will be minus and this will be positive. Okay, so now we will identify as what test we should do. Now my friend, in the question what we have got a sample size of 5, means n is 5. And for t-test, what was our criteria? Our criteria was that the population standard deviation has to be unknown and the sample size has to be less than 30. If both the conditions are being satisfied, then we can go with t-test. So both the conditions are getting satisfied here. The sample here is of 5 units. Okay, so we can go for t-test. Okay, now as we were discussing, we need to find the critical value, means this value. Critical value is the value which separates the rejection region from the acceptance region. If this is alpha, this is 1 minus alpha, this is the acceptance region and this is the rejection region. So we will be doing t-test. Okay, so in order to find the critical value, what we will do first, we will identify the critical value which is separating these two regions. Okay, from the T table, if you see on the board, you will find that from this particular table we find the value which is corresponding to the area of 0.05. Okay, now if you look in the T table, you will find that in the left hand side the degrees of freedom are given, and on the top row the values are provided, means the areas are provided. In this particular problem the number of samples is 5. Okay, so the degrees of freedom will be n minus 1, that is 5 minus 1. If you consider the column, leftmost column denoting the degrees of freedom, we will take degrees of freedom 4, and on the top row we will take the area which is denoting 0.05, because level of significance is 0.05. now if we go right hand side from 4 and from 0.05, if we come down the value at which these two points are intersecting, that will give us the critical value, the T value. It is 2.132. I believe that this is clear to you how we got 2.132. This 2.132 is your critical region. Okay, it is lying on the left side, means it will be minus. You are clear with this? Means this is the critical value which is separating the rejection region from the acceptance region, and you have seen how from the T table we have found out this value. Okay, now in the next step we need to find the test statistics. As we are doing the T-test, we had told that the test statistics means x bar minus u divide by standard deviation divide by root n. This is the sample size, this is the standard deviation of the sample, this is the population mean, and this is the sample mean. So we have got all these values. Okay, now let us put these values. So we need to find the sample mean. So if you see in the question, the prices of the 5 sampled products were given 69, 79, 89, 99 and 109. So we add up all the 5 values and divide by 5. So we get the average value or the sample mean value. So it is coming 89. So 89. And what was the population average mean? It was 100. So it's 100. Standard deviation was given 15.81. Divide by root n. Sample size is 5. So if you solve this, you will get minus 1.56. Okay. You can call this as the test statistics value. Okay. Now what is the final step? Final step is to draw the conclusion. How do we draw the conclusion? See, we have to plot this value in this normal distribution curve. Okay, we have to check whether this value is lying on the rejection region or the acceptance region. So if you see, if this is 0, see this is the mean of the population, the mean is 100 and the corresponding T value will be 0. So this side will be positive and this side will be negative. So minus 1.56 will be lying somewhere here. Since minus 2.132 is this one, so minus 1.56 will be lying somewhere here. Okay, that means the test statistic value is lying at this position, which is not in the red zone or not in the rejection zone. That means we cannot reject the null hypothesis. We accept the null hypothesis and reject the alternative hypothesis. Okay. So this is what we have discussed is the critical value approach or critical value method. We can do the same using p value approach. We will show that in another example. So we are done with the first example. I believe that you have understood the concepts of hypothesis testing and how you came to a conclusion. Okay, so let us go into another example. So friends, let us go through the question that is being shown on the board. The problem states that the average IQ of students for a school population is 100 with a standard deviation of 15. A researcher believes it is not the same and decides to test the average IQ of 75 students. The average IQ of the sample was found out to be 105. Now, is there enough evidence to suggest the claim of the researcher? We need to do this using hypothesis. Okay, we need to test this hypothesis. So if you carefully go through the question, you will find that the sample average IQ is given, that is 105. Okay, the sample size is also given, which is 75. Okay, the population average IQ is also given, that is 100, and the standard deviation of the population is giving is 15. The currently accepted value, that means the average IQ of students is currently accepted as 100. Now the researcher is claiming that it is not the same. It may be less than 100, it may be more than 100. The researcher has not specified whether it's a less than 100 or more than 100. It means we have to take that it is not equals to 100. It is a classic example of two-tailed test. Okay, the first step is to formulate the null hypothesis and alternative hypothesis. So if you go through the question, you will find that the average IQ of students which is currently accepted is 100. Now the researcher is claiming that it is not the same, it is not equals to 100. So this becomes your alternative hypothesis, this is your null hypothesis. So we are done with the first part. Okay, now the second part comes that we need to specify the level of significance. In the problem, the level of significance is not provided, so we take the level of significance which is most commonly used as 0.05. Okay, it is 0.05. The sample size is 75. The standard deviation of the population is 15. Okay, and the sample mean, okay, it is given as 105 and the population mean is 100. These are the values that we have in the question. Okay, and we need to plot this alpha value in the normal distribution curve. So let us begin by plotting this alpha value on the curve and see how the normal distribution curve looks like. So since it's a two-tailed test, the rejection region will be lying on both the tails. On both sides of the tail, the rejection region will be lying. And what will be the area under this curve? The area under this rejection region would be alpha by 2 on both sides. That means it would be 0.025. Means alpha value or the level of significance value of 0.05 will be symmetrically distributed at the two tail ends. Okay, now this is how the curve looks like, and this is the population mean which is 100, and the value corresponding to this would be 0. Whether you go for t-test or z-test, this value will be corresponding to 0, and on the right side of 0 you will get a positive value, on the left side of 0 you will be getting a negative value. Okay, the next step is to find the critical region. Now what is the critical region? The critical region or the critical value are these 2 points. Okay, the point which separates the rejection region from the acceptance region is the critical value. We need to find it using Z table or T table depending upon which test are we doing. Okay, so before finding the critical value, let us first determine what is the test that we are going to do. What is the hypothesis testing method that we will follow. Okay, so if you remember that the two criteria that needs to be fulfilled for t-test are: number 1, the standard deviation of the population should be unknown and the sample size should be less than 30. Okay, now in this question the sample size is 75 and the standard deviation of population is also known, That means both the criteria are not getting fulfilled. So we will go for ZTest. Okay. Now let us find the critical values using a Z table. Okay. Now what does this alpha signifies? The alpha value signifies the area under the rejection region. It is as simple as that. So now let us find the critical values using Z table. If you can see the Z table shown on the board, you will find that the Z value that is corresponding to area under the curve, which is 0.025, the corresponding Z value will give you the critical value. So it is 1.96. If you carefully watch the Z table, you will find that it is 1.96. It means it is 1.96 here and minus 1.96 this side, since it's a two-tailed test. So we have got the critical values. Now we will find the test statistics value or the Z value. So we are well aware of the formula. So what will be the formula of the test statistics? It will be x bar minus mu divided by SD divided by root n. Okay. This is the sample mean, this is the population mean, this is the standard deviation of the population, and this is the sample size. We have got all the values. What is the sample mean? It was 105 given in the question. And what is the population mean? It's 100. Okay, currently accepted value of the IQ of students. Standard deviation is 15 and n is 75, so it will be root 75. Now we need to solve this value. After solving this value, we will be getting a Z value or test statistics value of 2.89. Okay, so we have got a value of 2.89. So we have set up the null and the alternative hypothesis. We have plotted the level of significance on the normal distribution curve. We have found out what is the test that we are going to use. We have found out the critical values and we have also found out the Z value or the test statistics value. Now the final step is to draw the conclusion. How we will draw the conclusion? We will plot this value or the test statistics value or the Z value on this curve. Okay. So 2.89 will be lying somewhere here. Since it's 1.96, this is the increasing positive value, so 2.89 will be lying somewhere here. So it is lying on the red region, means it is lying on the rejection region. If it is lying on the rejection region, that means the null hypothesis has to be rejected. This is as simple as that. Okay, so we have got our answer that the null hypothesis has to be rejected, since there is not enough evidence to support and accept the null hypothesis. So we reject the null hypothesis. Okay, so I believe that this is clear to you. So this was the critical value approach. We can do the same using p-value approach. We will definitely solve such problems using p-value approach in the later videos. Okay. So friends, I believe that you have got the basic idea of hypothesis testing and you have got a clear idea about the concepts of Z-test and T-test. Okay. Now you know when to reject the null hypothesis and when to accept the null hypothesis. Okay. You have got a fair idea and you have seen why hypothesis testing is important in statistics. It is basically helping to draw conclusion and making decisions about the nature of populations. Okay, it is basically the proof of the data. It is basically the proof that your data is significant and did not occur by chance. Okay, in a nutshell, you can say that because of hypothesis testing in statistics, it is how you decide if something has really happened or not, or some experimental results, whether it is going to have positive effects or negative effects, or understanding the different groups. So it will help you in drawing conclusions regarding any claim. Thank you for watching this video. Please like, share and comment. and stay tuned for more videos on hypothesis testing. In the next videos of hypothesis testing, we will discuss about Z-test when we deal with proportions, and also we will discuss about F-test, chi-square test, ANOVA test and Fisher's distribution test. Till then, bye, take care and thank you once again.